Okay, let's do example 4. We'll finish it off. Example 4, determine the location of the coordinate of the point of intersection where the equation of the normal x equals pi and 2 meets the equation of the normal x equals 3 pi and 2 for the function x cos x. Okay, so the first thing I might do, this question's possibly complex unfamiliar, possibly complex familiar. The first thing I'm going to do is jump on Desmos function. You should do it in your graphic calculator and consider what it looks like at those points. Get a bit of an understanding. Y equals x times cos x looks like that, which is fun. And I need it for pi on 2 to 3 pi on 2. So I'm going to change my steps to be up in pi on 4. No, that's the wrong one, isn't it? That's my y. No, that is right. Pi on 4. Yep, there we go. That's going up in pi on 4s. And I'm just going to change the scale. It doesn't need to be that deep. So we'll go up to, say, 5. And we'll go from -2. So there it is there. Pi on 2, you can see, is showing as is 3 pi on 2. So there's pi on 2, 3 pi on 2 is there. So I might just move it a little bit across and I'll screenshot that. So it's an interesting function, but right now I don't care about that element of it. I just care about what it looks like at these values. So if I grab that and pop it on here, and you would be obviously looking at it on your calculator, and just fix up the things that need to be fixed. Remember, you should have your y and x marked. I can see that the normal to the curve at 3 pi on 2 is going to look something like this, and the normal to the curve at pi on 2 is going to look something like this, and they're going to meet somewhere here. Now 3 pi on 4, 3 pi is getting close to 10 divided by 4. This is about 2.4, and this is obviously about 4.5. I'm expecting somewhere 2.5, 4.5 as my answer. And that wasn't that hard to do. And you've got a graphics calculator. It's not quite as easy to do as this. And it's not quite as easy to see, but there's no reason why you can't quickly sketch it and just see, I'm expecting an answer in the first quadrant, somewhere down here between pi on 2 and 3 pi on 2, maybe a little bit closer to pi on 2 or whatever. You've got a bit of an understanding of the question. And if it's a complex, unfamiliar question, you've probably got the time too to play around with it. See if you've really hit something like that early. So let's do this. Firstly, y equals x cos x. I have to determine the gradient at pi on 2 and pi on 4. That's my first step. So, so step 1 is my gradients. And in part of doing step 1, I need to work out y dash. And what is the product rule question? So it's the derivative of the first multiplied by the second plus the derivative of the second multiplied by the first. So the derivative of x is 1. U equals x, u dash equals 1, v equals cos x, v dash equals negative sin x, and I get cos x, so 1 times cos x plus x times negative sin x, so it's equal to cos x minus x sin x, like that. And then I can say at x equals pi on 2, I get y dash is equal to cos of pi on 2 minus pi on 2 times sine of pi on 2. Now, hopefully you recall that 2 is 0. Sine of pi on 2 is 1. And so my gradient here is pi on 2. That's for that pi on 2 value. And over here at x equals 3 pi on 2, I get, so my gradient's, yeah, it should be, I feel like it should be positive though. Oh no, so that's my tangent gradient. There we go. This is MT. My apologies. My tangent gradient, which is this gradient here, is pi on 2. Yeah? And it is negative pi on 2, which makes sense. It is negative, and I'm happy with that. And my next one, x equals 3 pi on 2. I have y dash equals 3 pi on 2 minus 3 pi on 2 times sine, that's wrong, isn't it? 3 pi on 2. This is cos 3 pi on 2. What's cos 3 pi on 2? Really small, that's what it is. No, what is it? 0, good. And what's sine 3 pi? 1, so is it 1? Negative 1. So this comes out as 3 pi on 2. My gradient there. That's mt for the second point. So you can see here that that is quite steep and a positive gradient. This is quite shallow. These are my tangent gradients at the moment. So my normal gradients, we'll call this step 2. Mn, my normal gradient will be negative 1 over negative pi on 2, which is equal to 2 on pi. It reciprocates the denominator, and the negative makes it positive. Happy? You can put that in your calculator if you needed to. Mn is equal to negative 1 over 3 pi on 2. That's equal to negative 2 on 3 pi. It reciprocates the denominator, and it makes it negative now because there's only a single negative. Any questions on that? So it's still pretty tough, but we're getting there. We now have a gradient for both of our functions. I'm doing both functions simultaneously, but later on I'll probably separate and do them separately. So there's my gradients. I also need to find my y coordinates. So 3 at x equals pi on 2. You'll notice that y is equal to pi on 2 times cos pi on 2, which equals 0. So my coordinate here is pi on 2 comma 0. Does that match my graph? Yes, it does. You'll also notice that it obviously equals 0 over here as well. But again, just to fulfill my working requirements and to justify everything appropriately, 3 pi on 2 here, I get y is equal to some stuff, 3 pi on 2 times cos 3 pi 2, which also equals 0, and therefore we get 3 pi on 2 comma 0. Are we happy with that? Sorry? And now we need to find our functions. So I've got my gradient of the normal. I can't hear you. Oh, I did too. Sorry. Right. Thank you. And there's my coordinate. And my second function, there's my gradient, and there's my coordinate. So now I can find my linear functions. So that's step 4. And in step 4, I get y equals 2 on pi x plus c. And at pi on 2 comma 1, and by 1 I mean 0, I get 0 equals 2 on pi, and this is nice, times pi on 2 plus c. 2 on pi times pi on 2 is just 1, so my c value is equal to negative 1. And that's nice because I can see this drops down, potentially down to negative 1. Doesn't look like it on this graph, but it drops down to negative 1. You've got to keep in mind on this graph that my scale's actually out. So from here to here is 3, and from here to here is 3. So there's actually quite a significant scale mismatch, which is probably not a good idea on my part when I first set it up. But that's what makes a gradient deceptive. So you just got to be careful with that. Over here, I get y equals negative 2 on pi times 3 pi on 2, and plus c. And y, of course, is 0 in this case. And so I get a c value of 1. They all cancel out, but I get 0 equals negative 1 plus c. Of course, I get a c value of 1. And so that gives me the functions y equals 2 on pi x minus 1. And over here, y equals negative 2 on 3 pi x plus 1. So there's my two functions. Am I finished the question? This is going back to that stuff I was ranting about last term and not forgetting the chickens or whatever you want to call it. You've got to make sure that you go back and think about the question. It feels a bit like I finished the question because in terms of what you will do mostly in class, we have found the normal curves, the normal lines. So it feels like you're finished. question has that one extra step. So what do we need to do? Find where they intersect, which means we can use simultaneous equations to do that. And actually, these are already set up quite nicely for me. I've got y equals something and y equals, so I can eliminate the y values. See, for this to work, and this is step 5, which is our above and beyond step that could potentially make it the complex familiar question. We get this. 2 on pi x minus 1 is equal to negative 2 on 3 pi x plus 1. I've just cancelled out those y's. If y equals something and y equals something else, we want to find where they match. I can just let those two somethings be equal. And now I just solve this. I'm going to multiply by pi. I might multiply by 3 pi to start with. And that gives me 6x minus 3 pi is equal to negative 2x plus 3 pi. I'm going to add 3 pi to both sides and add 2x to both sides. And I get 8x is equal to 6 pi. X is equal to 3 pi on 4. And at x is equal to 3 pi on 4, y is equal to 2 on pi times 3 pi on 4 minus 1. So I've just taken that, substituting into our first equation. I could substitute in the second equation, so go back and think about that simultaneous equations work you did. This cancels out my pi's. 2 times 3 is 6 over 4. This is equal to 6 over 4 minus 1, which is equal to a half. Any questions? Now, if we go back, our deceptive gradient has meant that this is actually out. So I'm going to go back to the graph in a second, just explain what I mean by that deceptive gradient. But our point of intersection is at point of intersection at 3 pi on 4, comma. And so Desmos, if I go in, I'm not sure if you know that you can do this. If I go in here, I can zoom square. That will just change the scale. And then I can put those two functions we developed in. Y equals 2 over x. That's wrong. 2 over pi x minus 1. You can see that's the normal to the curve there. And the other one is, thank you, y equals negative 2 over 3 pi x plus 1. You see that goes through there. Our coordinate, which is the one that we got. So it worked. Our normal curves are more accurate there. If I change my scale back to what I had, which was something like, say, negative 1 to 10, not what is it? Oh, I don't want it to zoom square. Still zooming square. Oh, sorry. No, that's my x-axis. I'll leave that the same. So negative, what did I go up to? About 5, wasn't it? Negative 2 to 5. So that squashes it. That's the graph that we copied across. And you can see it doesn't quite look like a normal anymore. Because I've compressed it, it takes away that normal feel about it. So if I draw that normal, it's probably more like this, which is why we've got an intersection point up there. So it's a good point to make. If you're doing it on your calculator and you're trying to find things about the curves, your gradient will be deceptive if you've got not a square situation. You've got a scale indifference. Okay. Are there any questions on any of that? Cool. So your goal should be that by the end of today's lesson, you can do everything on here, but mainly that you're happy with everything up to example 3. That will mean that you're at the simple familiar, touching on complex familiar. If you can do that, you're in a good place. We can get to the rest of it. And then the exercise has some good harder questions as well. So if there's no other questions, I'm going to start checking homework in a minute. I'll just stop this.